Hello, this is Casey Blaha, an MD PhD student at the University of Illinois at Chicago College of Medicine. This video is part of our Survivors Advising Scientists educational program, a bidirectional educational platform meant to connect our communities and increase scientific literacy and engagement. Our goal is to bring everyone to the table for scientific discussions related to cancer, science, and therapies. This is video number 4, Confounding Variables. As a reminder, it might be nice to listen to or review the previous module called Experimental Variables, as it provides good background for this module. What is a confounding variable or factor? It is an unintended factor that affects the dependent variable or the outcome. Below, we will describe an example of an experiment in order to discuss the confounding variables. First, in this experiment, we have the independent variable, which is the total time, versus the dependent variable or outcome, and that is the amount of songs learned. The experiment is then broken into 2 groups, experimental and control group. The experimental group is children getting piano lessons 20 hours per week. The control group is infants getting piano lessons 0 hours per week. The researchers were interested in testing if the amount of time or hours of piano lessons affected the number of songs learned. We then need to consider if there are other confounding variables or unintended factors that might affect these results. In fact, the 2 participant groups are different. Infants will not learn songs on the piano regardless of how many hours of piano lessons. Therefore, this experiment does not properly address the research question related to piano lessons. The researchers wanted to determine if piano lessons, the independent variable, affected the number of songs learned. However, the age of the study participants is the confounding variable, which might affect or change the results. So let's review some of this terminology again and come up with more examples. First, you have the independent variable, or the intended cause. One example of this might be experimental medicine versus standard medicine, to see how these might affect the outcome. Then we have the dependent variable, or the effect or outcome. In this example, it might be something like tumor size. Finally, we have the confounding factor, or the unintended cause. In this example, patients receiving experimental medicine might have started with smaller tumor sizes than patients receiving standard medicine. Or, like the last example, age might be a factor or gender of participants. Now that we have gone through some examples and terminology, let's do an exercise. You want to test if a diet is effective at weight loss. Group A is the U.S. women's gymnastics team. They are given a standard diet. Group B is a group of senior citizens. They are given the experimental diet. What are some possible confounding factors when interpreting these results? Please feel free to pause the module and write down your answers. Is it A, amount of exercise done by each participant, B, age of participants, C, gender of participants, or D, all of the above? The answer is D, all of the above. There can be more than one confounding factor in experiments. For instance, A, the amount of exercise done by each participant. The U.S. women's gymnastics team is more likely to have more rigorous exercise regimens compared to a group of senior citizens, and this could drastically affect the weight loss results. A confounding factor is anything you think would affect the results, besides the independent variable you are testing. So how do we prevent confounding variables? A good experiment will make sure to control the variables so the experimental and control group are the exact same, except for modification of one independent variable the scientists are interested in. In other words, ideally, the control group and experimental group start the study as identical twins with no differences between them. This is a visualization of the previous slide with an example. As a reminder, in the experimental setup, you have a control and experimental group. In the control group, the independent variable is held constant. For instance, they receive the standard medicine. In the experimental group, the independent variable is experimentally changed by the researchers. For instance, they receive the experimental medicine. Ideally, both groups are identical in order to prevent confounding factors that might affect the results. Now that we've reviewed experimental variables and confounding factors, when evaluating experiments, here are some questions you can ask. What are the independent variables? Are the independent variables the only possible factors that cause the experimental measures? If not, what are possible confounding factors? What can you do to control for the confounding variables? This is the end of Module 4. Now the presenters would like to thank Dr. Kiriesky and the administrative staff of the University of Illinois Cancer Center for their support in this effort. Additionally, we'd like to give a special thank you to all the cancer patient advocates who provided feedback during the development of these modules. We'd also like to thank you for reviewing this module, and we invite you to send any feedback on this module or suggestions for future contact. Please feel free to move on to the next module, number 5, on experimental errors. Thanks again.